Mapchats.
Hello, and welcome to today's Map Chat. My name is Bernie Langer, and I'm a data analyst at PolicyMap. Mapchats is an online webinar series presented by PolicyMap, a national online mapping service that provides maps and data visualization tools with tens of thousands of data indicators related to demographics, housing, education, health, and more. Normally, our map chats cover a policy or data question, and we discuss how people have addressed that question with maps and spatial analysis. Today, we'll be talking about the maps themselves and how to make maps and other data visualizations so they'll be most effective in communicating the data. So we have some really great guests today, Jake Garcia from Foundation Center and Robert Cheetham from Azavea. We're going to start off the webinar with me talking a little about some of the color decisions we've made for our maps on PolicyMap, and then move to Jake, who will talk about different types of maps and visualizations for different situations. And then Robert will talk about using maps to show change over time. Afterwards, we'll have plenty of time to take questions from the audience. If you have a question at any point, just type it into the GoToWebinar control panel, and we'll answer at the end. Also, feel free to comment and follow along on Twitter with the hashtag Mapchats. All right, so I've been working at PolicyMap since before it was born in 2007. I'm mainly responsible for helping to keep our data catalog up to date, but also deal with some of the aspects of display, such as color. So the question I'm going to mainly be answering today is, why is PolicyMap purple? We've been asked that more and more recently, and the answer has been surprising to some people. So this is the default map when you log into PolicyMap, and so 99% of our users probably keep it at purple. And so the reasoning is not actually due to branding. It's not because our logo is purple. It's not because purple is a 2-time Pantone color of the year. And it's not because we're really big Prince fans. The reason is actually a little more interesting. So if we look at the color wheel, you can see there's actually not that many sort of varieties of colors for us to choose from. So I'll start off the bat by saying that yellow is hard to see, and it's not impossible but difficult to make a pretty clear map with yellow. Red. So here's a pretty red map, and when I look at this, I see these red areas and think that there's something bad about those areas. Like the area in the middle of Philadelphia here just looks something about it, is bad, maybe something we want to fix. In fact, this is a map of the percentage of people that bike to work. There's nothing really wrong with that as far as I can tell. So you want to be careful with the message that the color is portraying. Oftentimes, even when you are mapping something with a little bit of a negative connotation like crime, you still sometimes want to be careful about using red because it might make it look like you're making a statement about that area. So oftentimes people don't want to live in the red areas. So that's one of the reasons that red is not a default color. Here's a blue map. Blue is a nice color, but when I look at this map, it looks like one of those global warming, sea level rising kind of maps, because it's hard to tell in this case the separation between the blue of the ocean and the blue of the bay and the blue of the data on the map. So sometimes blue works really well, but if you're in an area with lots of water bodies, it can be a little bit confusing. I think green makes a really nice map. Green, it's a very positive color, usually something good, often kind of nature-y. Oftentimes it relates to money, so you might see green being areas with maybe higher income. But at the same time, if you have an area with parks, it can sort of run into the parkland. So you can see here Griffith Park and Topanga State Park in Los Angeles look like they might be part of the data being presented on the map rather than their own separate land use areas. So once you get through all that, what's left really is purple. And that is why our maps are purple. I think if you were maybe mapping people who were anti-royalty, purple might not be a good map to use. It has that connotation, but otherwise there aren't too many connotations one way or the other, so it really fits with everything. And then the other color that I haven't mentioned is orange. So what we do is we use orange for negative values. So in this map, purple is showing areas where the population has increased, and orange is showing areas where population has gone down. And so then after that, there's other factors in determining how the specific colors we should use on the map. We just talked about hue. If you look at this little chart here, which is just taken, I think, right from Microsoft Excel, hue is what you see when you look left to right across that chart. It's just really what we think of as color. Saturation is the up and down. If it's very unsaturated, it's going to be closer to gray, whereas if it's very saturated, the color is going to be really bold and easy to see. And then lightness is the slider on the right. So once you've chosen your hue and your saturation, the lighter or darker it is the lightness. So when talking about saturation, this is what a PolicyMap looks like in general. If we made it really saturated, it would look like this, and it definitely captures your eye more and pops out a little bit. But at the same time, it looks a little bit, I think, less professional. A lot of our users will be using PolicyMap images for reports and maybe grant applications. And in that case, you probably don't want something where the color is this saturated. And again, compare it to how PolicyMap normally looks. Again, very saturated, really captures your eye. And this is our standard. And then you can make it less saturated, and that would be this. And it's almost as if it's black and white. And to me, it's a very classy look, very, very professional, but at the same time, it's not going to capture your eye as much. So if you have a report where you have a map in it, you probably really want people to look at that map because it might tell more than all the text you write can say. So we have it a little bit more saturated. The color is going to draw the eye in a little bit more. And then there's lightness. So we normally use lightness to differentiate between maybe different data values. So again, if you look at this, the lighter areas here, areas with lower population, the darker areas have a higher population. To talk in detail about lightness gets into a whole lot of math. This is how we ended up determining a formula for our lightness levels. And I'm not going to get into that today. I might write about it on our blog at some point in the future. But I do want to talk a little bit about one aspect of lightness and why it's important. I had my buddy Claude draw up this little painting here for us. And when you look at it, the sun sort of seems to float in the sky. It's kind of playing tricks with the eyes. And the reason for that actually is if we look at the same picture in black and white, the sun just disappears. And that's because it's the same tone and the same level of saturation, or the same hue and the same level of saturation as the surrounding sky, looking at it again, but a different hue. And the eye actually perceives lightness with a different biologically than how it perceives hue. And so when you have something that has the same lightness but a different hue, it does sort of play some tricks in the mind, and it's a little bit hard to look at sometimes. And some of our early maps have suffered from that. Actually, I love looking at this map. It makes me feel like I'm in a candy shop. But it can be a little bit difficult just for the eyes and brain to process because of the way that we interpret color. So with that said, we'll move on to the next presentation. Next presentation is going to be by Jake Garcia. As the Vice President of Data and Technology Strategy at Foundation Center, Jake Garcia is responsible for leading and integrating 4 subdepartments related to data and technology, including application development, web services, information technology, and data acquisition and architecture. He also oversees the development of data visualization, mapping, and machine learning applications, and their implementation in the Foundation Center's internal processes and external products. As a geographer and programmer, he's worked on GIS projects for NASA, Al Gore's climate project, the City of New York, and the US Army. He received an MA in geography from Hunter College and a BA in political science from Brown University. And without further ado, I will give it to Jake.
Thank you. Hi, everybody. Again, I'm Jake Garcia. Now, Bernie, do I have control over the navigation?
Yes. So if you hit, there you go.
Great. Okay. So what I'm going to cover today is a couple of components of one of our new data visualization applications called Foundation Maps. And so part of it's going to be geographic mapping. Another component is going to be network mapping, which is not geographic, but it can have a geographic basis. And I'll kind of explain that in a second. First, for those of you who are not familiar with the Foundation Center, we're a nonprofit. We're based in New York. We've got branch offices around the country. We collect data on foundations in the United States and foundations around the world, and the nonprofits who receive grants from those foundations. So we've got several free products and services like GrantSpace and GrantCraft, and we have news like Philanthropy News Digest. But the bottom there, you see 2 of our subscription products. We've got Foundation Directory Online and now Foundation Maps. And in it, we've got 140,000 foundations, like 350,000 nonprofits who've received grants from those foundations, and overall about 4 million grants, but that number is about to jump up to about 6 million in a couple of months, and then we're going to be adding several million grants per year. In addition to the subscription products, and we actually derive a lot of, using that grant data and foundation data, we actually build these things that we call landscapes. So up on the left there you see washfunders.org. This is a public-facing site. It's about water, sanitation, and hygiene funding around the world. The funding from foundations and from governments. BMA Funders is Black Male Achievement, shows funding in the United States for African American boys and men. And then Advancing Human Rights, which is at humanrights.foundationcenter.org. This is kind of an aggregate summary of human rights funding around the world. So we take our basic data, then create visualizations, and then add case studies and a bunch of other contextual things so that people who are interested in one particular topic can kind of get good access to see what's going on in the field. At the Foundation Center, we've got like 150 employees. We've got millions of folks who look at our properties and websites and things around the world. But there's a couple of things that we hear all the time. This one's like, how can I scan the landscape of funding? This is something that foundations, I interviewed about 40 foundations about a year ago, and 38 of the 40 literally said this sentence. It said, scan the landscape, or how can I get a landscape scan, or some kind of word jumble of this. So it's a very popular question. They just want to know where's the funding going, who's the biggest funder, that kind of thing. Nonprofits often ask, who'd be the best funder for me? So you might be a nonprofit working on, animal, rescue in Brooklyn. Well, there's other animal rescue nonprofits in Brooklyn, and who are their biggest funders? That's kind of one geographic kind of question we might help them with. But there's lots of different parameters that make up for the best funder, and the geography, in some cases, is just one piece of the puzzle. What other nonprofits or foundations should I partner with? That question comes up a lot because nonprofits know that foundations like it when nonprofits collaborate, and foundations themselves more often than used to be the case are partnering together to solve problems. Like, why, if I've got $1 million and you got $1 million, why should I just spend my $1 million and pretend that the other million doesn't exist? Maybe we should work together on solving the problem. And then lastly, what regions need the help the most? Let's say lots of foundations are giving lots of money for a project in Ghana, but no one's spending any money in Sierra Leone. That's like an obvious thing. If a foundation is trying to figure out geographically where to spend their money, they can see that there's, while no problems have been solved in any particular place, there are definitely regions that can be identified that have an acute problem with very little investment from foundations and from governments. So here's kind of when you go to Foundation Maps, and this is maps.foundationcenter.org. This is kind of a login screen, and we're trying to basically answer those questions for customers. When you log in, you get a bubble map. Each one of these bubbles, these orange bubbles, represents the locations of recipients around the world. And you can see in this little summary at the top, there's 3.5 million grants in this set, $236 billion. This is since 2006. And you can click on each bubble. Each one represents the recipients of grants in any particular country. For those who are GIS programmers, there's some really interesting stuff that we did with geohashing so that you can actually zoom in and get, we've got the addresses of every recipient, or almost every recipient. So you can get all the way down to the street corner level, but being able to aggregate 360,000 points without breaking your browser and without using an Esri product was actually a challenge, which is, it's pretty wonky, so I'll save it in case if anybody has a question about it, I'm glad to answer it later. We can do trend analysis over time. This is funding for education and arts and culture and health around the world. You can see there maybe that education actually far outstrips health. What I did not draw on here was the line for science. Science would be at the very bottom. You wouldn't be able to see it above the x-axis there. Science funding is woefully low, but education, health funding, and arts funding typically are pretty good. And then here we have a choropleth map. So like the maps from PolicyMap, we've got these shaded thematic maps at different scales. So this is a country map, so where it's darker green, here we used green, and it does happen to represent money, so I guess green was the right choice in this case. You can actually zoom in and look at state by state, state to state, and then county by county and city by city in some cases. And this is showing basically the relative places where amounts of money are being spent around the world, not just the recipient location. One of the important considerations when doing maps like this, we use point data. I mean, those orange bubbles you saw before. Let's see if I can get back to this. These represent the locations of recipients where you've got a point, you've got an actual address where their point lies, right? The choropleth map, you see China over there, you see India. There might be a grant for $1 million, and it goes to Kenya, India, China, and Mexico, let's say. And we don't exactly know how those dollars got split between those 4 countries. So we've got to figure out how to say, okay, that $1 million applies to each of the countries. We're not going to split it into 4 quarters, but we need that grant to show up in all these places when you click on them. So there's a lot of cartographic decisions you need to make when talking about money and regions. And again, there's no specific street corner that it goes to, so point data would not be useful in this case. So let's say in one of these case studies we're looking at Kenya. Say we're looking at recipients in Kenya of education dollars, and at this level I believe it's province, so there's a dot in the middle of each province. And then as you zoom in, you're going to get again down to the street corners of the recipients of grants in Kenya for education. Then you can click over, and here we've got what we call the list view. What we found is that with customers or people or researchers or journalists, at first you're going to look at a map and you say, wow, maybe I wouldn't say wow about that map. Maybe I'd say wow about that map. In the end, though, people really want a list. So HEVOS and the UN High Commission for Refugees and Research China, they're the top recipients of education grants in Kenya. The next one, here are the top funders. This is the one everybody wants. The top funders for education in Kenya, let's say I'm working on an education project and I'm in Nairobi, I would say, okay, well, I think my first targeted list is going to be Hewlett, National Postal Code Lottery in Amsterdam, Ford, Goldman Sachs, Gates, etc. This is like your prospect list, or this is, if you're a funder, these are the people to partner with. So you used a map to kind of validate that you were getting to the right place, but in the end, this is usually what people kind of want. Say, I need to figure this part out. Here is a choropleth, or thematic map showing just Florida. And in this case, I don't know if you can see the little buttons, but it's as if you chose Florida as the state for the geo area served, meaning it doesn't matter where the recipient's located. It's the area of benefit is Florida, and then where the subject of the grants is environment. And you can see a shaded map where white means no dollars, and up to dark green where it means more money comparatively in this small this small region. And then you click on Miami-Dade, and you can get your basically your prospect list. Or you could say, you know what, the regions don't matter to me. I don't care about money so much. I'm actually going to be going around downtown Miami, and I want to see where these environmental nonprofits are located. And you can see, and you can then click around on the bubbles, and you get down the street corner level. Now about connections, and this is where it got really interesting for us, because people were saying, I made a prospect list of all my funders, and then I looked at my competition. I looked at all their funders, and I saw where the overlap was, and I took that overlap and I made that that's something interesting. But what about those funders who funded my competition but did not fund me? That's kind of what this shows here. On the left, we got the World Wildlife Fund, and and it goes to their top funders. Then it goes to the top recipients from those funders. And this is like the 6 degrees of Kevin Bacon. Now this one does not reflect a subject or anything like that, so it's not a very good prospect list. But it starts to show you the kind of degrees of separation between nonprofits and foundations. So you could say, if you got Hewlett over here on the right, Hewlett is 3 degrees separated from the World Wildlife Fund. But then we took it another level and kind of exploded it a little bit. So let's go back to the Florida and environment case. Here we said, okay, you know what, I've got Florida and environment. Show me the universe of this. Show me who's connected to who and who's out. So, and you got orange is nonprofit, and this kind of bluey teal is foundations, and you're going to find these networks, and they're all kind of connected, but then sometimes on the outside you get these little outliers that are not connected to anybody. But this foundation gave to this nonprofit also got money from this foundation also gave to this nonprofit. So you find lots of little communities, very tightly woven or very loosely knit communities. And this is actually what funders are particularly interested in. This is another one, Florida and the environment is kind of zoomed out. You can see that looks like a constellation. It looks like there's a little universe. All these people you can imagine them all the program officers being at the same cocktail party, and then over here, these guys weren't invited or weren't interested or something, It's not literally the way it works, but this shows the kind of a density that's pretty interesting, because foundations often ask the question, what happens if I wasn't in this network? What happens if I stopped funding environment in Florida? What would happen to this network? Is it good to have a really dense network where there's lots of coverage, lots of funders funding lots of nonprofits? Or is it good to have a central big funder and then lots of peripheral ones? These are the kinds of questions that foundations frequently are asking us. Again, this is zooming in. You can zoom around, it's animated. If we have time during the question and answer segment, be glad to do a live demo of this, and we can take questions from anybody who's attending, and we can try to see how some of these look. And these are animated, and you can drag them and drop them around. And again, so Florida is a factor. The geo is a factor. It helps us narrow down the data. Environment is a factor. It helps us narrow down the grants. But then, we don't need to see it on a map. You're actually trying to see how tightly woven this network is, and then maybe give you leads for people to partner with and leads for people who might be good funders for you. I'll end it there. Thanks a lot for listening. And again, during the question and answer session, be more than glad to answer any questions and hopefully do a live demo too.
Great, thank you so much. That was very interesting. And so our next panelist is going to be Robert Cheetham. Robert is the founder and CEO of Azavea, a software firm that applies geospatial technology for civic and social impact. While he is a technology entrepreneur today, Robert was originally trained as a landscape architect and lived for several years in Japan, where he worked in local government. Prior to founding Azavea, he was an analyst and developer for the Philadelphia Police Department and the City of Philadelphia. And so I'll hand it over to Robert.
All right, thanks so much. I'm going to talk about, Azavea works on a lot of different kinds of projects related to maps and cartography. But I'm actually going to, instead of talking about some of our projects, I'm going to talk more generally about different approaches to mixing geospatial and time-related data. So here we go. So I've called this Adventures in the Space-Time Continuum, which sounds a little bit like Star Trek, but I'm going to show a lot of historical maps as well, and I'll speak briefly about those. So Azavea is, we're about 45 people. We're a small technology business based in Philadelphia. We build geospatial web applications similar to the ones that we've just seen, projects like PolicyMap and the Foundation Center Map, though we haven't actually worked on those. So we're a mix of software developers, designers, data analysts, and so on. We're also what's known as a B corporation, so we're a for-profit company, but we operate with a social mission, and an organization called B Labs certifies B corporations, a bit like LEED certification for buildings. So we are an organization that's really aimed at a triple bottom line, both people, planet, and profits. Our mission, there are a lot of other B corporations that you might recognize, places like Patagonia, Ben & Jerry's, and so on. Our mission is around applying geospatial technology for civic and social impact, as well as advancing the state-of-the-art through research. We do that in a bunch of different ways. We work on web and data analytics projects that have a civic or social component to them. We release a lot of our work under open licenses. We have a number of research partnerships with universities. We allocate about 10% of people's time for learning and research. We donate a share of our profits each year, and we operate a program called Summer of Maps. And these are a few of the ways that we pursue our mission. But more relevant for today, we do a lot of work around data and visualization. So in our kitchen, we hang interesting visualization charts and posters and all sorts of things, and that's part of the culture at Azavea as well. So I thought I'd build on some of the cartography information and learning that we heard from Jake and Bernie, and talk a little bit about how we might add time to cartography. This is a drawing that many of you have probably seen. It's been made famous by Edward Tufte in his books. It's and the reason it's quite prominent is it mixes so many different types of information in a single spare drawing. And this is a diagram of Napoleon's march to Moscow and his return home, and the thickness of the line represents the size of the army as it is slowly whittled away. There's also a geographic component because he's marching across Europe, as well as a number of other time and other components. When we start adding time to the geography component that we usually have in maps, this kind of overloading of information into a single screen becomes the way that we generally have to operate. So I'm going to go through a few different ways that people have done this historically, and then talk about some more contemporary ones as well. So a classical way that people have organized time-based information related to geography is something as simple as a table. Here we're seeing some train tables. A second way that people often do this is through a tree or a branching structure. Here we're looking at a family tree, a genealogical structure, and this is another important way. Here's another example of the same sort of thing. So tables, trees, and branching structures were developed at specific points in time in order to improve people's organization of certain kinds of information. Here's a more contemporary example. This just came out recently. This is comes from it's a screenshot from a visual introduction to machine learning that was noted on the Flowing Data site yesterday or today. It doesn't do justice here with a screenshot. It's actually animated, and as you scroll through the page, these animated graphics outline this tree structure as a visual explanation of how this particular machine learning approach works. Second, I guess around a third important approach is timelines. They vary from very simple like this, history of a company, to those that add a little bit of color but are still fairly simple, to a fairly simple one but where the information is so dense at a particular point in time that we end up having to stack them up. We can also get non-linear timelines. This is an attempt to diagram the storyline in the Chrono series of video games, and the timeline loops back on itself at different points in time, but still a very simple, straightforward way to graphically represent time. And here's a much more complex one where we have a lot of different dimensions represented in a single timeline. This is radiation released after the Fukushima nuclear accident. So we've got a typical timeline, but we've got multiple components to it. It's annotated in color along the way, and those colors each represent another piece of information. A fourth important way to, that time gets represented is through something people call graphic transition, where we're essentially using something similar to a timeline, but we use the second dimension, the Y dimension, to indicate additional information. Here's an old one from the 1700s, a new chart of history. Here's a more color version from the 20th century, showing the same sort of thing. But here's a really fun one that you can find online or in poster form. The history of pop music and rock and roll, developed by Garcia and Rari. Zooming into that, you can see how the time is still this linear component, but the thickness and stacking of things and the convergence of them represents another kind of information. Here's a similar sort of thing outlining the story of the Lord of the Rings and the Star Wars trilogy from XKCD. Pretty interesting. I think these can be ordered as posters now too. And here's a digital equivalent of the same in terms of the ideological history of the Supreme Court. And these are a mix of color, time, vertical stacking to add multiple dimensions. A fifth important technique that pre-exists digital work is combines explicit geography with some kind of timeline. So this is a Tufte recrafting of a explanation about how a storm develops in his book Visual Explanations. But we have the linear timeline along the bottom, juxtaposed against the geographic space across the top. We also get explicit geography combined with color and annotation. This is looking at the evolution of state boundaries in the United States. As we have shifted to digital over the last couple of decades, we both have some new challenges that we didn't necessarily have with paper, but also a lot of new opportunities. Challenges, we have relatively low resolution. Even our high resolution TV screens and video monitors are much lower resolution than paper and ink. And we also often have a constrained canvas shape or size. Even when I was putting together slides for this talk today, I had to work within a specific canvas area that was defined by the PowerPoint slide and the GoToWebinar software and so on. But we also gain a number of important things around interactivity and being able to have things that are dynamic based on incoming data. So here are a few examples of where this plays out with time. This is using time for using a thematic overlay to show time. This is a project we worked on several years ago with a research project at the University of Pennsylvania called Mapping Du Bois. And it combined contemporary property data with Du Bois' historic Philadelphia Negro project. And here the slider is not a time slider, but because this was a very linear space that he had originally surveyed, it moves you across that, that linear space. But here, each map layer represents a different point in time. We can adjust things in a similar way with symbology changes by using transparency, texture, and color in a much more dynamic way than we would be able to with paper. Some more contemporary devices that people use for this sort of thing are things like split screens. In this case, this is a visualizing change between the two decennial censuses, 2000 and 2010. It's a project done by the Center for Urban Research, and there's a splitter bar in the middle. You can, it's probably a little difficult to see, but you can move that splitter bar back and forth and look at how, in this case, ethnic origin and race are changing in the New York region between the 10-year periods. A little bit different use of split screens, literally the same geographic area that's locked with the pan and zoom, but with very different data sets from two different periods of time. This is a project with the Nature Conservancy called Coastal Resilience that Azavea worked on. And we're also obviously very familiar today with something that was relatively rare 20 years ago, a route on a map with a sequence of directions along the way. These are the driving directions to go from Azavea's office to the reinvestment fund and the PolicyMap team. This map was just released recently from Atlas Obscura, Guide to Literary Road Trips, and this is a sequence of potential road trips you can take across the country that trace a nonfiction book. Again, the overlay of time on top of geographic space. Animation is increasingly common. Animation can sometimes be tough to absorb without replaying it over and over, but this is a really great example put together as an experiment by a group called Hint.fm that replays back in a compressed time period wind, speed, and direction across the United States. Really cool map. The screenshot doesn't do it justice, but I highly recommend taking a look at it if you haven't seen it before. Another digital technique that borrows from the analog world as well is the juxtaposition of a map with a timeline below it. This is a project released by YouTube recently called YouTube Trends. Combines a map of trending videos with timelines and information on those top videos. A similar map plus chart juxtaposition. This is a project Azavea worked on some years ago with the University of Richmond around visualizing emancipation. And the timeline here is the Civil War period. And there's an ability to play this back, so it uses animation to some extent, but also the ability to juxtapose an amount of something over time. In this particular case, what they called emancipation events, with Union Army troop movements and the locations of those events over time. Pretty interesting combination of geography and time for research purposes. And then we have a number of new tools that I think people are making increasingly good use of around story maps, things that combine photographs with photography with stories in a sequential look. This is Esri's story map tool in the Anthropocene Atlas. There's a similar open source public effort called Map Story that provides similar kinds of tools. And the CartoDB product also provides a tool called Odyssey.js that enables you to do similar kinds of storytelling with a mix of annotation, maps, and photos. And then finally, some of the most amazing things we can do with digital is around the interactivity. This is a wonderful example that I love that CartoDB developed in New York City called Manhattan Henge or NYC Henge, identifying those locations and times in the city where you can see the sun through the buildings through the Manhattan grid. If you've never seen this before, it's really a lot of fun. And I also wanted to wrap up with a look toward the future and new ways in which I think time and space are going to come together in the future for us. This is a project that Azavea has been developing for several years called HunchLab. HunchLab combines space and time events, so in this case crime events, and where there are calls for service with advanced statistics, machine learning, and tools like that to identify the locations of highest risk for crime in order to improve patrols. So a police officer patrol. So when a police officer is not responding to a 911 call, where should they be patrolling in order to prevent crime or reduce their response time? So this kind of mix of geography, time, statistics, and the ability to generate these kinds of forecasts using large arrays of computing machines is, I think, pretty exciting and points to some interesting applications in the future. I then had a few slides of just walking through how some of these different techniques get applied on a single topic and the number of different ways that can be, the diversity of ways that someone can explore something. This is a train timeline that we saw earlier in a chart, a timetable. Here's that same, not literally the same timeline, but a similar sort of timetable translated into both geographic and time space from the 1900s. This is a Paris-Lyon trains. Here's a more complex version that's then adds another element of geography to it. This in the Java railway line in Indonesia, first with an overlay of Dutch and then later Japanese. Fairly complex, but combines a whole lot of information into a very small space. Here's a more contemporary implementation of the same thing using those two drawings as an inspiration. This is the California Department of Transportation adding ridership numbers into that with thickness and color of the lines. And here's an interactive version of the same thing, enabling people to explore potential cuts that were on the table for the Metra rail system developed by Nicolas Rougeau. So I was going to close with a few of my favorite cartography books. There's some really wonderful books available today. This is one that's quite old, though, going back to the 1950s or 60s by Jacques Bertin, Semiology of Graphics. Esri Press brought this back into the print a few years ago. It's a really classic text, pre-digital, but with a lot of ideas that translate to the digital realm really well. Stephen Few's Show Me the Numbers book around primarily charts and graphs, but ways to improve explanation of information with them. These are Tufte books that many of you have probably heard of. A book called The Cartographer's Toolkit, published by Gretchen Peterson, includes just a wonderful range of color combinations, line weight, a lot of font examples and how font interacts with a map to improve explanation. And Cynthia Brewer's Designing Better Maps book. I understand there's a new edition of this coming out in the fall, but this is also a really great cartography text. And then one of the places I took some of those historic maps was from a book called Cartographies of Time, history of how timelines and maps come together. Other places I like to look at are Flowing Data. Some of you have probably seen this before. It's a daily blog of interesting visualizations, and the person that runs that, Nathan Yao, has published some really great books on the subject. History Shots sells posters of this kind of time space visualization, as does a place called Time Plots. And finally, I'll close with our Summer of Maps program in case there are nonprofit organizations in the audience that are interested in working with spatial analysis. This is a spatial analysis grant program where we match up nonprofit organizations with great data sets with students who are studying spatial analysis, and they work over the course of 12 weeks to implement those projects. So take a look at summerofmaps.com if you're interested in that. And with that, I'll wrap up. Thanks very much.
All right, thanks a lot. That was a really great presentation. And I'll say as we start the questions that a lot of the questions are about where a lot of those maps come from. So maybe afterwards we'll be able to come up with a list of links so people can see where a lot of those maps come from, so they can look at a lot of, especially the live ones that that you have to see online to experience. Our first question from Christina is for Robert. With all of these fascinating maps, why are there so many high validity maps such as USGS? Why are so many high validity maps such as USGS so difficult to read and interpret?
I can't speak for those particular maps, but I do think that some of the clarity that was required working with paper and the need for clarity has been lost in the transition to digital. And the fact that we can do so many things is often a temptation that none of us can resist, and we do a lot of the things that maybe we can do but aren't necessarily going to add to clarity. So that's one potential issue, and I can't speak to National Geographic maps per se. I think some of the National Geographic maps are actually incredibly beautiful. I think a second concern that ends up making maps and other visualizations complex is the desire to cater to multiple audiences. So, and in doing so, the map ends up trying to do too much. I think, for example, a map like the typical Google Maps navigation map that we saw, was the cartography there was really designed for navigation, for a single purpose. In our experience, that's a horrible map to display data on top of. That kind of background canvas, you want to be much more muted so that the data you're trying to display and articulate to the end user becomes is much clearer and more apparent, and the map just becomes a reference that sort of recedes into the background. So I think it's important that for different purposes and for different audiences, we end up picking cartographic techniques and tools and base maps that are appropriate for that particular purpose.
Great, and I guess I'll pass a similar version of the question on to Jake. In terms of simplicity versus detail, is that an issue that you sometimes have to wrestle with when developing your maps and your platforms?
Yeah, definitely. So I'm a geographer. There's another geographer here on staff. We have a couple of data scientists, but then we'll put something together and usually try to do something simple, but then someone who's in the business side, or maybe who works with our customers in the library, they say, you guys, there's so much more data you could be showing. We want to show the foundations, we want to show the nonprofits, show locations of schools, show the demographic change over time, show the rich areas, the poor areas, high educational attainment, low educational attainment, and where money's going all at the same time. And as Robert was saying, it's almost impossible to really show all of those in a really clear, discoverable way at the same time, unless there's some kind of ratio or some kind of simple algorithm you're going to run that actually has something very derived, simple kind of factor you could show. So it ends up you make some tough choices. In our case with foundation maps, we just show the recipients, or just show the foundations, or just show demographics in some cases, or you can maybe draw a shape on the map and then get a couple of answers out of that, but not something where it's like everything in the kitchen sink is all of a sudden at your disposal. If you ever, I guess the question before might have been about some of the U.S. Geological Survey maps, or maybe if anybody's just looked for data from the U.S. Census website, for instance. I mean, it's awful. There's just so many things because they have to be complete. So making the choices about what you really want to show, what gives your end user the most value, ends up sometimes being so simple you can't believe that you had so many people working on something for so long to create something that just comes out and says the answer is 5, and here's the orange bubble that says that. So it's a long process to get to something that simple.
Great. And so another question for you, Jake. This is from both Eliza and from Brenda, which is on your site, what sort of platform do you use? Is it something that you've developed internally, or is it something that where you work with an outside vendor?
We built it internally, and that's because we have a couple people that worked on this stuff traditionally. So we happen to have a couple of GIS programmers and data visualization folks, but we used a lot of components that were, libraries and things that were already in existence. So for the mapping stuff, we use Leaflet, which is an open source JavaScript library. And then, we had to do some customization for the geohashing so that we could aggregate the bubbles accordingly. But Leaflet is the main thing for the JavaScript part. And then for the constellations, we've got the bubbles that float around. You can drag and drop them and stuff. That is using D3. So it's also a popular JavaScript engine. So people can actually take some of the stuff that's already out there, and you can actually combine D3 and Leaflet, both JavaScript, and do some really cool stuff with that. You can even do animations on a map over time with Leaflet and D3. So it takes some customization work, but a lot of the tools are out there, and you don't have to spend money on an expensive license for anything.
And I'll pass that question also to you, Robert. I know that you didn't talk too much about the maps that you've developed, but do you like working? What do you like working with?
For visualization tools, our contemporary tools are probably really similar. D3 is a very common toolkit that we use. Leaflet's very good. In terms of back-end processing tools, it really depends on the scenario. So sometimes we're using Esri products, sometimes we're using open source tools, sometimes we're using tools like CartoDB, and it really depends on the scenario. For very high performance, like big data sets, we might be using open source tools like GeoMesa and GeoTrellis. For more routine map generation, we might be using tools like ArcGIS, Mapnik, or CartoDB. So it varies quite a bit. But for the actual front-end visualization tools, these days almost everything is in JavaScript. 5 years ago, we might have been using a mix of Flex and Flash and JavaScript. But JavaScript, CSS, and the HTML5 are the key components and the frameworks that enable us to do that sort of thing. The open source tools available today are just really amazing and quite powerful.
All right, great.
Yeah, Jake, I forgot to add one more thing. As Robert mentioned, the back-end stuff. We also use SQL Server, Microsoft SQL Server, some of the number aggregation, but we would much prefer to use open source. So for some of the number crunching and algorithmic stuff, we use a lot of Python libraries. But the open source stuff is fantastic now, and there's huge communities of folks doing that. So I completely agree with Robert on that.
All right, we have a question I like here, which this is from Mary, comes in through Twitter. She asks, have Americans gotten better at reading maps, or are these great tools only going to communicate with a small slice of viewers? And I think that sort of goes back to the first question we asked about simplicity versus detail. But I wonder if either of you want to speak to sort of different levels of complexities for different audiences.
I'm not sure it's unique to Americans, but I think the lives that we live and the activities we carry out in the environments we live in end up inevitably shaping the skills that we have. I think someone living in the early 20th century would have found a smartphone with spoken directions and an interactive display, and the mix of 2 dimensions and 3 dimensions and the flipping back and forth between those, and aerial photography and roads and traffic information all jammed into one device. Incredibly bewildering, but we have gradually developed skills for dealing with that level of complexity and can use that many different kinds of information together and switch between them at appropriate points in time. So I do think we don't have the similar kinds of wayfinding skills, however, that we had, hundreds of years ago. Not many people learn how to use a compass anymore, let alone a sextant. A few people, I think, learn how to read signs of directions that are embedded in a forest or on the surface of a tree or a rock, and that would have been second nature to someone living not that long ago. So I think the kinds of skills we have end up trained and developed through the kinds of activities we carry out. And I'd say there's a lot more maps today than there was when I was growing up. I think there's more data available that is geographic, and that's providing tremendous opportunity to display data in useful, interesting ways that are intuitive for some people. Though I'd add not everyone. While our company builds applications based on maps and geography, as Jake showed us earlier, there's certain kinds of data that a map doesn't make any sense, even if it's geographic data. And there are lots of folks who don't necessarily don't find a map intuitive, which seems odd to someone who does find a map intuitive. But we all have different kinds of minds and consume and process information in different ways. So I think it's important for tools like PolicyMap and the Foundation Center map to be able to provide multiple visualization approaches in order to adapt to those different cognitive styles.
Well, I still use a sextant because you never know when Google Maps is going to shut down and you're going to be left to celestial navigation.
I am totally impressed that you know how to use a sextant.
So there's one more question, kind of along the same lines, and maybe Jake, you can start. This is from Ruth, which is, how do you walk the line between aesthetic beauty and intellectual intelligibility? She asks, how would you decide when to provide less detail in favor of design or vice versa? So not just in terms of showing detail, but showing just attractive design. Is there ever a trade-off that you have to make?
I guess that definitely is. Part of it goes along with the previous question and the question before that. Making those kinds of decisions is a little bit tricky. I mean, and I'm sure Robert's the same way. I just love looking at maps no matter what. So even if it doesn't tell me anything, I enjoy looking at it. So the hard part for us is making sure that you're helping the person make the right decision. So if you're just trying to make something that's beautiful that'll catch their eyeball and get them to stay there, that's where you do the kind of pretty part. But then to get them coming back, they actually need to find it useful. Then they'll come back a second and third time. Robert, I know we only have a couple minutes left. I want to make sure we have enough time for Robert to answer.
Yeah, I would say that a beautiful map is important. So just what Jake said, I'd add that a lot of the key decisions are not necessarily just the map or the actual visualization, but subtle things like the placement of a button and the wording on the button and the color and how it comes together with a drop-down, so that the actual interactivity, the layout of the page and the way in which the eye and the mind work together to interact with the data can be as critical to making something simple and useful as how eye-catching or visually appealing the map might be. That kind of user experience design is something I think we still have a lot to learn about, and is an area where there's a tremendous opportunity for impact.
All right. Thanks. That's a really good answer. And I think with that, it looks like we've come to the end of the hour. And I want to thank both of you, Robert Cheetham and Jake Garcia. This is just really interesting. I think all of us could be stealing a lot of what we've learned from each other for our presentations going forward, or our projects going forward. And hopefully there's a lot that our audience can use as well. We'll be putting this webinar up online at www.policymap.com/mapchats. We'll also be sending all of our viewers a survey. So please take a minute, let us know how you like the presentation and any suggestions you might have for future map chats that you want to see. Our next map chat, which is coming up soon, is going to be on the challenges and uses of neighborhood level health indicators. That's going to be hosted by our own Morgan Robinson, and more information about that will be coming soon. I also want to take a moment to let everyone know that in addition to the tools offered by Foundation Center and Azavea, PolicyMap offers quick and easy mapping and data visualization tools. There is a wealth of data and features available for PolicyMap subscribers, and no mapping expertise is necessary. In addition, we offer site licenses to cities and universities across the US with customized access to many of the indicators that you've seen, some of the ones much more detailed than population change and people who bike to work, but more than that. And if you haven't checked out PolicyMap yet, I encourage you to sign up for a free 7-day trial to explore how it can help you and your organization use data to make smart decisions. So thanks again for joining us. Thanks again to both of our presenters. And if you have any questions, feel free to get in touch. Have a good day.